Okay, this is Mr. Peterson continuing with the notes for Algebra 2, Section 8.5, and this is page 3 of 4. What we're going to learn how to do on this page is solve logarithmic equations, and you're going to start by getting the logarithm isolated. If there's two or more logarithms, so you can see an example here, I'm pointing at it, you have to put them together on the same side and then actually consolidate using the log rules. Alright, so here we go. I'm going to get the logarithm by itself by adding 5 to both sides. And then you're ready to take this base to the other side, but you have to switch formats. It's currently a logarithm, but over here it's just a base. So you can see I took 4 to the third equals 2x going around the world there. And I'll divide both sides by 2 here. And that, if you type it, I'm going to type it and store it here. Okay, 4 raised to the third power, I know that's 64, divided by 2 stored for x. And you get 32. Now, these problems must be checked. They generate extraneous answers that, if you don't check them, are going to come back and bite you. So I'm going to take that answer that's already stored and type the left side, math alpha math. And you can see I've typed the left-hand side here, and I'm hoping it equals -2. So that answer is legitimate, which you confirm with a little check mark. Okay, this next one has the logarithm already isolated, so I'm ready to go around the world. 4 to the negative second power equals 2x plus 5, or 2x minus 5. Now I could make that 1 over 4 squared, which would be 1 over 16, but I'm just going to leave it like that for now. And we'll divide by 2 here. And we'll let our calculator do all of that heavy lifting here. So, 4 raised to the -2 plus 5, all divided by 2, and we'll store it while we do it. So, 2.5313. Now that it's stored, we're going to check it. Math alpha math. And that should give -2. That's a legitimate answer. Well done. Okay. So divide both sides by 3 here, and you get the common logarithm of x minus 2 equals 4/3. Now the base here is 10, and it's invisible. A common logarithm always has base 10. So I'm going to come over here with a base 10 underneath this. Now I add 2 to both sides. Calculate that answer and store it and check it. $23.5443. I believe your homework asks for 3 decimal places of accuracy instead of 4. That one's already stored. Let's see if the original problem rings true. And we get the 4 that we were hoping for when we got the original problem. Okay, legitimate answer, ahoy. Alright, subtract 1 off both sides to get your logarithm all by itself. Then you go 2 to the 5th on the other side. Your base is 2, so make sure you put that underneath the little exponent of 5. And we're going to subtract 4 off both sides. And divide by -3. And let's see what this gives us. 2 to the 5th minus 4. Divided by -3, I'm going to store that as I find it. Okay, -9 1/3 is what that is. Okay, I've got it stored already. Math alpha math will give me that log base option. 4 minus 3x and then plus 1. We're hoping that all equals 6 like it's supposed to. There we go. Legitimate answer. Okay, it's getting a little trickier here. This next one, you can see there's 2 logarithms. What you have to do is make one logarithm out that by using the rules. So I'm going to take this 2 and make an exponent out of it. So log of x squared, that's the power rule. We learned that last time. And then I'm going to take this addition and cash it in for a multiplication inside the logarithm. Now I'm finally ready to take this base 10 over to the other side. I'll divide by 6 here. And I'll take the square root of both sides, which gives me 2 separate answers here. The positive and negative versions of each other. So I'm going to start with the positive version. 10 to the third over 6, which is 1,000 over 6. Square root of 1,000 divided by 6, and that is 12.9099. And if I check that out, going up here, 2 common log of x plus the common log of 6. Oops, I have to put a parenthesis in there before I say plus the common log of 6. And that gives an error, but I think I typed it wrong. Oh, I didn't store that number. That's why. Store that for x, and then try again here, and that one works just fine. It gives 3. I knew that was a legitimate answer. Now the other one is just the negative version of that. So I'm going to come up here and grab that and insert a negative sign at the very front. Second insert negative sign. Now if I go up and grab this, it's going to fail this time. Yep. That was an extraneous answer. So you cross it out and write extraneous, just a gentle line through it. The reason it's extraneous, anytime you have an x value, excuse me, a logarithm with a negative number inside of it, or 0 inside of it, it will fail. So if the result of this part of it is a negative number, any logarithm with a negative number, you'll get this error message because it's undefined. Okay, so let me show you that in action here with a natural logarithm of some negative number, and you'll see it's going to freak at us. Okay. You can't have a negative number inside a logarithm, or 0 inside of a logarithm. Okay, this one here has a minus sign, which means when you put these logs together, you have to use the quotient rule, x over x plus 3. And you get 5 to the negative first power, which is 1/5. And I'm going to cross multiply 5x that way, and x plus 3 times 1 the other way. So that's 4x equals 3. And that tells me that x has to be 3/4, or at least I think it is. So I'm going to store that 3 divided by 4. And type in the original. Hopefully that equals -1, and we're good. That was a legitimate answer. Okay, we haven't had any where we have extraneous answers other than this one here. I think that's going to change on this one. Alright, so we're going to bring this log back so it joins its friend over here. Log base 2 of the one that was already here, plus log base 2 of the one, there's the one from the other side, and we still have this 5 on the right. The addition between two logs becomes a product, so that's the product rule of logs. X plus 1 times x plus 5. And we've got a 5 over there. So now I'm going to go 2 to the 5th to get rid of this logarithm. I'm also going to FOIL that out. So x squared, you got a 5x and a 4x is a 6x. And last times last is 5. And over here you have 2 to the 5th, which is just 32. So I'm going to subtract 32 off this side here. Okay, then we factor this using the star method. And you get x plus 9 and x minus 3 equals 0. So that tells me x equals negative 9 and x equals 3. And this one's extraneous. You can see that pretty quickly here. If you plug in negative 9, you get a negative number inside that logarithm. That one actually works, and I'll check it some other time, but it does. Okay, the 4 in front becomes a power. That's the power rule. And then we consolidate, put it together with a division inside of the logarithm. I'll take the base 3 over the other side. As I cancel here, subtracting exponents gives x squared, and over here 3 to the 6th, that's 729. So x is equal to positive or negative 729, square root of that. So it's positive or negative 27. Excuse me. Probably blew your ears out there. And the negative here is extraneous, so we're just going to scribble it out here and write negative 27 is extraneous, but this one, positive 27, is going to check. Let's try it. 27 stored for x, and then go 4 times the log base 3 of x. I used math alpha math there. Minus 2 base 3 of x, and we're hoping this equals 6. Legitimate. Okay, so that's page 3 of the notes for Algebra 2, Section 8.5.